Next we have number 36 where we have to find dr d theta from this equation cos r plus cos theta equals r theta. So the solution starts like this. We of course are going to differentiate both sides with respect to theta implicitly, assuming that r is a differentiable function of theta. You can write those things in the beginning, but I am just simply writing we have this. So doing that differentiation, the left hand side will be this by the sum rule for differentiation, dd theta of cos r plus dd theta of cos theta, and the right hand side is the dd theta of r theta. Now to carry out this first differentiation, you have to apply the chain rule because you are looking at a composite function here. There are two functions, the outer cosine function and the inner function r, which is some function of theta. So differentiating the outer function with respect to r, that means keeping the inner room r intact, you get minus sine r. Then you multiply that with the derivative of the inner room with respect to theta, that is dr d theta. And this is just minus sine theta. On the right hand side, you have to apply the product rule. If you keep r intact and differentiate theta with respect to theta, you get 1, that means r times 1 or r. Plus then you keep theta as it is and differentiate r with respect to theta. So that's how you get this second term. And now we are going to gather those terms together which have dr d theta and push everything to the other side. Say I keep this minus sin r dr d theta where it is and push this other term on the right hand side to that side. So it becomes minus theta dr d theta. Similarly, on the right hand side, I keep this r and bring this minus sin theta over to this side. So it becomes plus sin theta. And then you take dr d theta common out, actually minus dr d theta common out from the left hand side. So that's how you get this minus of sin r plus theta times dr d theta, and the right hand side is r plus sin theta. So we just need one more step. So this is our derivative. Dr d theta equals r plus sin theta divided by minus of sin r plus theta, which you can write like this, minus of r plus sin theta divided by theta plus sin r. Next, let us see number 44. Here also, like the previous one, an equation is given relating x and y. Xy plus y squared equals 1. And from this we have to find the value of the second derivative of y with respect to x, not dy dx, d squared by dx squared at the point 0, minus 1. We of course start the solution by differentiating both sides of the given equation with respect to x implicitly once. Okay, that only we can do, and then we have to differentiate once more. So doing it once, we get this. On the left hand side, using the sum rule for derivatives, we have ddx of xy plus ddx of y squared, and on the right hand side it's 0 because 1 is constant. Now here you have to apply the product rule. Keeping x as it is, you differentiate y with respect to x, that gives you dy dx. Then in the next term you keep y and differentiate x. Differentiating x, you get 1, so that's why you have y. And to do this differentiation, you have to apply the chain rule. First you differentiate y squared with respect to y, that gives you 2y times the derivative of y with respect to x. Now we push this term not having dy dx to the right side. So it becomes minus y, and on the left side if we take dy dx common out from the first and third term, we get x plus 2y as the other factor. And then we divide both sides by this, obtaining this expression for dy dx. And now we have to differentiate once more with respect to x to get the second derivative. Now if you want, you can do that differentiation here. Okay, immediately obtaining d squared by dx squared, but this is a little complicated. If you want, you can do it, but you will have to apply the quotient rule, and then there also dy dx will appear. So instead what we will do is this. We will differentiate both sides of this equation with respect to x. But before we do that though, Let us also see what the value of dy dx is at this given point 0 comma minus 1, because we are going to need it, and that calculation is this. In place of y you are going to put minus 1, and in place of x you would put 0. So this of course does not have any effect. 2 times minus 1 is minus 2, and minus 1 times minus 1 is 1. So 1 divided by minus 2 or minus 1 divided by 2. And now to find the second derivative, we are going to differentiate this. So we first write what we will initially get from that differentiation, applying the sum rule to these three terms, d dx of this x times dy dx plus the derivative of y with respect to x, which is just dy dx, plus d dx of 2y times dy dx. We have also carefully enclosed these things within brackets to indicate what it is that we are differentiating. And the right hand side of course is 0, because d dx of 0 is 0. Then in the next line we carefully calculate these two derivatives by the product rule of course. If you keep x as it is and differentiate dy dx with respect to x, then you get the second derivative, plus then you keep the first derivative dy dx as it is and differentiate x, which will give you 1, so you get dy dx, plus already there was 1 dy dx, okay. And then next comes this, plus, actually I should have done one more step, but I did it at once. First 2 comes out by the constant multiple rule, and then we apply product rule on the product y times dy dx. This time if you keep dy dx as it is and differentiate y with respect to x, you get another dy dx. So you are having square here, the square of the first derivative, plus 2y. If you this time keep y intact and differentiate this with respect to x, you get the second derivative, that is equal to 0. So you can already see that because we are not actually required to find an expression for the second derivative, but rather its value when x is 0 and y is minus 1. So you already see that if you substitute x equal to 0 here, this term is vanishing. So instead of wasting time trying to find an expression for the second derivative from this equation, we are going to put the values here itself. So we do just that. At the point, we stop the calculation here momentarily, and then we write at the point 0 comma minus 1, we have this. If you put x equal to 0, this term becomes 0, and what is the value of dy dx? There we have calculated it, and it is minus 1 divided by 2. So minus 1 divided by 2 minus 1 divided by 2 plus 2 times the square of minus 1 divided by 2. Plus 2 times y is minus 1 times the second derivative. Now we just have to find what this value is from this equation. There was a small mistake in the notation here. I should have written like this instead of simply writing d squared by dx squared, because that notation alone without this bar and this point denotes the derivative, second derivative, as a function of x. This means the value of that function at the point 0 comma minus 1. So this is how we should write it. So minus 1 over 2 and minus 1 over 2 give us minus 1. What will this be? 1 divided by 4 times 2 is 1 divided by 2 minus 2 times this, that is equal to 0. Now minus 1 plus 1 over 2 is minus 1 over 2, and if we move this minus 2 times the second derivative over to that side, it becomes 2 times the second derivative. And then after dividing both sides by 2, this is our second derivative value, minus 1 divided by 4 at the point 0 comma minus 1.